Hello, everyone. My name is Dr. Josue Sanford from the University of Florida Citrus Research and Education Center. Today, I am presenting our irrigation science special issue entitled Advancing Salinity and Nutrient Management for Irrigation Science. This special issue brings together research from around the world, addressing one of agriculture's greatest challenges, how to produce more food with less water while maintaining soil health and nutrient efficiency under increasingly stressful environmental conditions. So before we dive in, to understand why this special issue is important, we need to start with the global challenge. Agriculture remains the largest consumer of fresh water worldwide. At the same time, many regions are facing drought, erratic rainfall, groundwater depletion, and increasing competition for water resources. More than 300 million hectares are equipped for irrigation globally, yet water withdrawals remain much higher than actual crop requirements. This gap highlights major inefficiencies. Meanwhile, regions such as Africa have tremendous opportunities for irrigation expansion, but this growth must occur sustainably. Therefore, improving irrigation efficiency is no longer optional. It is essential. So to evaluate the scale of the challenge, here are some numbers to illustrate the magnitude of the problem. Perhaps the most alarming statistic here is that approximately 30% of agricultural land worldwide is already affected by salinity. This means that while irrigation helps increase production, poor irrigation management can simultaneously degrade soil quality. The challenge we face is not simply delivering water to crops, but we have to ensure we deliver the right amount of water while preventing salt accumulation and maximizing nutrient use efficiency. Now, due to the evolution of irrigation technologies over the past 3 or 4 decades, agriculture has moved from the traditional surface irrigation towards sprinkler systems, drip irrigation, and highly precise automated systems. Today's technology allows us to apply water according to the crop demand, soil conditions, and weather forecasts. Several studies in this special issue demonstrate that precision irrigation improves water use efficiency while maintaining or even increasing crop yields. The most common themes is simple. Every drop of water must produce value and not go to waste. Now, in terms of salinity and soil management, one consequence of increasing water scarcity is the growing use of lower quality irrigation water. When saline water is used repeatedly, salts accumulate in the root zone and reduce crop productivity. Many studies in this special issue focus on understanding and managing salinity through precision irrigation, biochar amendment, mulching, and soil water monitoring. The message is then clear. Salinity is not simply a soil problem. It's fundamentally a water management problem. If we manage water well, we will manage the soil salinity problem. Now, we've seen that water and nutrient management are closely linked. Whenever irrigation is poorly managed, nutrients are often lost through leaching, runoff, or inefficient uptake. Many papers in this issue explored fertigation strategies, variable rate fertilizer applications, and integrated nutrient management. These approaches improve nutrient use efficiency while also reducing environmental impacts. In other words, irrigation management is increasingly becoming nutrient management. As I said before, we manage irrigation well, we manage salinity, we manage nutrient as well. Now, in terms of water quality, we have to tell that not many regions have the luxury of relying solely on high quality fresh water. So some growers are increasingly using reclaimed water, brackish water, or desalinated water. While these sources provide additional water supplies, they also introduce new challenges related to salinity, nutrient balance, greenhouse gas emissions, and economic feasibility. So several papers in this issue are really evaluated practical solutions to make alternative water sources safer and more sustainable for agriculture. Now, we have also to consider some environmental and regional considerations. There is no one size fits all. One important lesson from this collection in this issue is that there is no universal irrigation solution. A strategy that works in Florida may not work in China or Spain or Africa. So we have to consider climate, soil type, water quality, and crop characteristics while we are making our management decisions. So the studies included in this issue demonstrate that the importance of adapting irrigation practices to local conditions while using modern monitoring tools to guide the decision making. In this slide, we highlight where irrigation is heading in the future. So we have advancing in sensors technology, soil moisture sensor technology, remote sensing technologies, simulation models, and decision support tools that are becoming more and more important in the irrigation water management. So models such as AquaCrop allow researchers and growers to evaluate irrigation strategies before implementing them in the field. So before they start setting up irrigation system, they have a good insight in terms of how much water the plant needs, how much they have to apply, when to fertigate, when to apply fertilizers, so they can apply these in the field with less and less errors. So the future of irrigation lies in integrating water management, salinity management, and nutrient management into a single decision-making framework. So now, some approaches in research is one of the strengths of this collection. Because of the diversity of approaches they use, we can explore a panoply, a huge array of solutions for irrigation water management. So the collection includes field experiments, greenhouse studies, simulation modeling, remote sensing applications, and spatial analysis. By combining these approaches, researchers were able to address irrigation challenges from multiple scales, from soil protocols and routes all the way to regional water management. So now, so what? What are the implications for growers and managers? The ultimate goal of irrigation research is to provide useful insight solutions for growers and water managers. The studies in this issue consistently show that precision irrigation, deficit irrigation strategies, fertigation, and data-driven scheduling can reduce water use while also maintaining productivity. These findings offer practical pathways toward more resilient and sustainable agriculture system. Now, let's see the special issue in terms of overall performance. The special issue attracted approximately 100 manuscripts submissions from researchers around the world. After rigorous peer review, only 20 papers were selected. The accepted papers covered 5 major themes: precision irrigation, water management, fertigation, salinization, and automated irrigation scheduling. Together, these papers provide a comprehensive view of current advances in irrigation science. So now, we have selected some of those studies here in terms of highlights. We have several studies that demonstrated the effectiveness of precision irrigation strategies. Like, for example, the study conducted by Atta et al. In citrus growth in sandy soil in Florida. It showed that applying approximately 78% of crop evapotranspiration improved root survival and nutrient water uptake. Other studies reported substantial improvement in water use efficiency through precision sprinkler irrigation and subsurface irrigation systems. A recurring finding was that more water does not necessarily mean higher yields. So strategic water application often performs better than excessive irrigation. Another common theme was the salinity management in those papers that were published. So researchers demonstrated that controlling soil water conditions can significantly reduce salt accumulation while maintaining productivity. Modeling studies also identified irrigation schedules that minimized salinity risks, while field studies showed how tillage practices and irrigation management can improve crop performance in saline environments. These findings are particularly important as agriculture increasingly relies on lower water quality for water sources for irrigation. Another theme discussed in those papers were nutrient management and fertigation. This group of studies focus on particularly improving nutrient efficiency. So researchers found that combining irrigation management with biochar, organic amendments, alternate wetting and drying, and optimized fertigation strategies can significantly improve nutrient availability while reducing resource use. The overall lesson is that nutrients and water should be managed together rather than independently. So in summary, I would like to conclude with 4 key messages for this special issue. First, precision irrigation is essential for improving water productivity. Second, salinity management will become increasingly important as water scarcity intensifies. Third, integrating irrigation and nutrient management improves both productivity and environmental sustainability. And finally, successful irrigation solutions must be adapted to local productivity and environmental sustainability. And finally, successful irrigation solutions must be adapted to local conditions while leveraging new technologies and decision support tools. Together, these advances will help agriculture produce more with fewer resources while protecting soil and water for future generations, which is exactly the definition of sustainability. So thank you for your attention. I would like to acknowledge the co-authors of this special issue, Dr. Davie Kadyampakeni, Dr. Ray Anderson, Dr. Michael Schmidt, and all the authors, reviewers, and the editorial team who contributed to this special issue.